the chat here. Just getting things ready. I found the bug in my thing. It was just that I had built the tool chain under a different user, and I'd done a whole bunch of experimental stuff, and that was not kosher. So we're going to start here. Hey, okay, this is part 2, I guess, of live stream number 9. Really, in part 1, I designed and built some of these boards. Let's see if I can get it to focus here. There we go. I got it to built some of these boards and got them printed and populated. And now we're going to see if we can flash them some firmware and see what some of these analog signals look like. And if I have any hope, which I probably don't, of being able to see what the signals coming off the lighthouses look like. Honestly, I think I'd be lucky just to get the thing to synthesize an extra voltage rail tonight. But let's just get started and see where we end up. So I'm just going to plug these in. Power and all that. Let's see, that one's ground, and that's blue, that's red, and it's rebooting wildly like it did before, but that's to be expected. Let's reset it here in bootloader mode, and I should have here thing. Let's take burn and sear term. Oh, those are flipped. Die. Okay. Are there streaming issues right now? I think it's fine. Okay, leaving. See here what happens if I reboot it. Still has a problem. Okay. Make clean. Make all. Make burn. Uh-oh. Oh, great. So maybe I was wrong. Maybe there is something else going on. That would be really disappointing. Let's make sure I built that right. Open SDK. Yeah, that's all correct. I would feel really embarrassed if this is a bust again. I just programmed one. It just worked. What am I doing wrong? Well, I'm going to hopefully get moving shortly here, trying to figure out what is going on. I've actually never had this problem. Okay, so that works. Okay, definitely a firmware that works. So it means that it might actually be a hardware problem of some sort, or something, maybe. Very strange. Ground. Okay, reboot it. It's broken. So that means something is wrong with this one. Let's probe it out. What is going on here? I checked between some pins. So let's check between that and what should be 3 volts. Yeah, it looks like 3 volts. All the places 3 volts should be. Doesn't matter. That doesn't really matter. Does that matter? No, I don't think it matters. Okay, let's check over here. 0 volts should be on GPIO 15, which it is. 3.3. Oh, that's weird. Oh, that's because that's GPIO 2 in the light. Okay, that's fair. Actually, you know what I could do? Just going to try shorting it out and powering it on. Nope, that doesn't do it. Something wrong? Maybe they're defective. Nothing. Okay, so those don't work, but this one does. They're the same board. What is going on? Yeah, I've just never seen this problem before, and yeah. I mean, I've used ESP8266s for so long that, you'd figure that if it was a problem like that, I would recognize it from, something that like, oh, every time that happens, that means this is wrong. But I guess there's always new problems in the world that I couldn't find. Oh, let me find another board to test again. Let's just try this one. Let's try this one. Yes, that is definitely, this thing is definitely hardware related. Okay, I guess it's time to start busting out something to debug this. I mean, there are some unusual things I'm doing. I don't normally set it up this way with GPIO 2 wired up this way, but it shouldn't be a problem. I guess those are normally famous last words, but let's get out the soldering iron. That's GPIO 2 there. Nothing. So that didn't fix it. The other thing I could do is, if I have any solder, I can short out GPIO 15, since I normally do have that shorted. Need a bigger blob of solder. Let's reset that. Nothing. Well, that's weird. Okay, I'll do that, Ben. I will give that a shot. Oh, it's just... Actually, as it isn't changing any pins before it, should be doing its thing. So that delay is a little unusual. I don't normally do that. Make all burn and sear term. Backwards? Try that. Ah, yeah, that's what it should be. Okay, let's see what it says now. It looks like it's just the wrong boot mode, but that doesn't make any sense. Let's see, how are these set up? So that should be shorted. That's also shorted. That's open. It's open. Compare those to 3.3 volts. Resistance. Resistance. That's the same I have here. For some reason, this is not entering the normal boot mode. I'll bet you he never burned his lips. Yeah, actually, that's a good point. I do have GitHub cnlore useful commands. Oh, what is that called? I don't remember. Repositories useful? No. No. Oh gosh, there's a script somewhere I have for this. me see if I can find on my laptop. Aha! Which one is this? This is, yeah. That what 0 means. I think 0 means it's successful. Hey, it's telling me stuff. Okay, what is it telling me? RF cal. Oh, interesting. Oh. Okay. Thank you for telling me to search that. As it turns out, this is a really good point. The RF cal feature is set differently on this hardware. I don't know why it would be set differently, but okay, maybe that should be part of ESP82XX. I never even thought of that. How do I do that actually? You know what? I did it over at GitHub CMore Swag is 2017. Okay, where is this used? Did I miswrite it? Oh, I did. Okay, so I should, right now, what I should probably do is copy git esp, actually it would be ESP8266, ESP non-OS SDK, actually, IoT SDK, and in here it's under bin, ESP init data default.bin. Let's see, how am I going to do that? I think if I just copy this into here, it'll just know to do it, maybe. We can try that. Yes, it's writing the new bin, so it may or may not just work. It just worked. Hey, Paul, thank you for that. That was a really good point. I really should have just tried to see what it was telling me. Normally, I'm just too lazy to execute the one command that switches the baud rate to the boot baud rate of 7440. Okay, now we can actually go do something. So I'm going to edit user main.c, and in here I am going to enable the I2S subsystem, because that seems like an important thing to have. And then I think what I'm going to do is build some sort of state machine that handles, by the way, those ones are being printed from the interrupt. So now inside of here, what I can do is I can edit the this interrupt here, wherever that is, to do my bidding, basically. that's in here. So I'm going to just, for now, comment all this out. Boop, boop. And static and charge pump state equals 0. Switch. Actually, I could do something a little more clever than that. Let's take a look. What is the user main? I'm going to want to do something in here to configure the charge pump pins. And let's see what those pins are. Those pins are GPIO 13 and GPIO 14. So I go over and look at, I don't remember where that is. It's somewhere in ESP82XX. I don't remember what he did with that. Christoph basically rewrote a huge swath of this code and moved a ton of stuff around. I barely know where anything is anymore. Let's see here. Command GPIO, is this? That's complicated. Yeah, let's just do it that way. That feels like it's easiest. So that's 12, 13, 14. So 12, 13, 14. And, oh gosh, how does that work? Just copy and paste the code. And in user main, what I'm going to do is configure I'm going to configure the outputs here. So do I think that sets it up as GPIO. There's some better way of doing this that's like the new way, but I've completely forgotten what it is. Anyway, once this is configured or something, maybe, I can then go and in here change some of those values and close some of these tabs since I don't have enough brain cells for all of them. So under ESP82XX, include xxutil, is that it? Yeah. Pin out. What I can do is I can specify or equals BV13 or BV14, and that will enable the output. And oh, I'm sorry, I have to do in dir output. Dir. And then I can set the outputs. And okay, let's see if that does what I think it does. It should drive the 2 pins high. Actually, first, let's make sure the 2 pins are low, and then we'll drive them high. So right here, this pin is very high. That pin is not very high. Why is that pin so high? Doesn't make any sense. There's nothing on there except a capacitor. That's weird. Well, whatever. Let's just see what happens when I set these. So I think that's the right mode. Okay, 323 and 163. So that's not right. I'll just do this the old way since I remember how to do that, sort of. Ooh, I could copy from here. In here somewhere there is the GPIO thing, which should just work. I thought of a problem, though, that might be an issue. I don't know if the I2S bus works if you remap the pins to be GPIOs that can't be GPIOs. So that could be a problem. I'm going to have to take a look at that. For right now. Yeah, I did the same thing here. Maybe I should just give up and just accept. Oh no, okay, so 0 to 12, 13, 14. So 0 to 12, function GPIO 13, function GPIO 14. That's 3. Let's see, do those agree? I already deleted the other stuff, so oh well. Let's check these pins. I see 3.3 volts, and I see 3.3 volts. Now, let's also make sure that the I2S interrupt is still firing, because I totally might have messed that up. Nope, I2S interrupt is still firing. This is spectacular. So now what I can do is I can then, so I'm out set and I can out clear. And what I can do is inside of this code right here, which is being executed just continuously non-stop, I can then use the thing. It's supposed to go -5 to 5, but yeah, not quite gonna get there. But we'll see what we actually get. So, so charge pump state. So the signals have to go 1 off, 2 on off, 1 on off, 2 on off, 1 on off, 2 on off, 1 on off, 2 on off. I think that's the pattern. Let's just try a pattern. We'll see what happens. So switch. Charge pump state ++. Case 0 would be both of them off. So pin out, clear. Case 1, 2, 3, 4. Or I guess it would be. Case 1 would be clear 14, but set 13. One, two, three. Then I would clear them again, and then I would set the other one. And I guess I won't even really have to clear it again. 1, 2, 3, set, and then I guess I just reset it here. Charge pump state equals 0. Break. And that could actually just be the default case. Okay, let's see what happens. Oh, something's wrong. Forgot to close curly brace. PWM timers on the ESP are not a normal thing, so it's just not a friendly environment. Even the actual systems normally nowadays, they use the firmware PWMs. They don't even use the real one. That's like coming directly from Espressif. It's just the ESP32. Now that's got a ton of real like all the PWMs and all of that, but not this guy. Okay, that's not working. It's because clear should be 13, 14. That should hopefully set it. .83, 0.83, and that's super lame. 4.9. That's barely 5 volts. That is just terrible. Okay, let's try a different thing here. What happens if I turn one on like a pulse train? So that would be both off, set 13, set 14, then clear 13. Okay, let's see what voltage we're getting now. Still pretty bad. Well, the circuit's doing something. The circuit is not uploaded. Maybe I should be working on this in Git. Tell you what, I'll go spend 5 minutes and do that right now. SP8266 Lighthouse, I guess we would call it. Let me go close off everything I've opened. Man, that's such a letdown that the charge pump is that lame. I would have totally expected it to have been better than that. Maybe those diodes just have a bigger forward drop than I expected. forgotten how to initialize that. ESP82XX. He has an example in here somewhere. Where did he put it? Let's try this. Charge pump failure is probably a blessing in disguise. Are you suggesting that maybe something is going to use up a ton of current, and if it was working, I'd blow it out? Because I'd totally believe you. Because I really don't have that much protection. But it's nice because the ESP8266 pins are like really tolerant to higher voltages, and if you go high enough, eventually they'll clamp down. But you got to go pretty high before it messes with the chip. Ben, I think I can clobber the problem. So, okay, there's really two ways I could go about this. The one way that I was thinking is I have, here, I'll pull open Charles CAD. Let me push this first. So the first way I was thinking about having it is you have a ESP 32 that's a master for a whole bunch of these little slaves that are all sitting out here. And what I wanted to do is only have to run 2 wires to them and have the charge pump sitting in them. This seems like an increasingly stupid idea, especially since it is going to produce kind of a nastier signal. But what it would buy me is that I'd be able to just arbitrarily have a single one and be able to provide the power locally. But the alternative would be to have a battery along with the this guy, the 8285, and then within here have the wow, that's a really terrible thing going in. But have these be completely self-contained. They'd also have like a little IMU. And then the charge pump becomes much more attractive. So I really wanted to at least give it a shot first. I was hoping to just... So, yes, I thought about using one with a lower voltage, but I just couldn't find any good ones. When I went to DigiKey, I actually made an order for several of them. I do intend to try them out eventually, but I haven't gotten a chance to try them out. I was picking up like just some general purpose op amps and just, okay, 12 megahertz one there. I don't even know what that is. Let's see. 15 megahertz. These were okay op amps, and they would operate at a slightly lower voltage, but oh, that one won't. this one would. But it just, I don't know. I want to do crazy things. I want to try it out. This one will operate within the right range and all. I might be going back to it, but yeah, I just don't know. Let's just do the charge pump thing first because it's fun. And if this fails miserably, okay, I'll give up. Oh, you know what? That's probably happening way too slow. Let's increase the frequency of the charge pump. Let's see. So let's make sure we can still build it. Yes, we can still build it. Okay. User main, and then in here I'm going to open up I2S duplex and I2S duplex. What was I doing? Oh yeah, I'm going to have to update the frequency. So let's bump that up. So instead of dividing by 80,000, let's just increase the frequency. Actually, it should just be make burn. Nope, still 5.2, 5.3 volts. It's just not going to cut it. So that's interesting. The second stage isn't getting anything. That's odd. Okay, time for us to go get out a little bit more of big guns as far as analyzing is concerned. I was able to borrow this little Sele logic analyzer. And I just realized I've never installed the hardware or the software for that on this computer here, so I'm definitely going to have to do that. Also, while I'm at this, I should probably wire on some terminals so I can monitor the pins. So, now, actually, before I get much further, I misspelled analyzer. Maybe it's working. I'll find out soon. First thing I'm going to solder on is the ground. Let's do that over here so I don't destroy my roommate's table. Can you guys see that? Yeah, I guess you can. I'm amplifying nanoamps. You are completely correct. I don't think this is going to work. but I have never let ridiculous odds stand in between me and learning some things. Huh. Okay, this is getting ridiculous. Okay. So that's that one. For right now, let's also monitor the 2 charge pump pins. And let's monitor some of the ones along the way on the way out. Can't remember what the maximum voltage Yes, Ben. That's actually a really good point. I could have gotten around all of this and just plugged the stupid thing into a power supply and gone from there. That would be a reasonable way to do it. I've already started down this path, though. And I normally don't have the Sele, so it was just by luck that my friend loaned me the Sele this time. Ben, are you a hardware engineer or a software engineer? Uh-oh. Oh no. I made a solder blob. Oh no, I missed Ben's answer. Oh, I'm a software engineer who's about 10 years farther down the same path you're on. Cool. I actually got my degree in computer engineering, and then I went back to get my master's in computer science. And then I realized I didn't like computer science, but I was stuck in it. So I do hardware on the weekends. Except in LibSurvive, which I don't know how I ended up getting stuck with, because that's all software, and so I just have to hope that my friends are smart enough to help out with any of the higher level mathy stuff, because I am not math savvy. done a lot of embedded work and a lot of crazy projects. Yeah, I hope to someday get to the point where my projects, if I even get started, it will be a feat, because to get started will be something unbelievably difficult. Okay, so plug in the ground. That is a huge loop. That is so bad. I wish these were shorter leads. So 0 will be phase 1. 1 will be phase 2. Let's get some more pins here. Three, 2, 4, and 5. That sounds confusing. I've never even... I mean, I guess it's necessary for higher frequency stuff, but... Okay. Let's see, what does this thing look like? That is interesting. That is not... Not what I would expect. I guess that makes sense. So it's pushing against there. Why is this one? Let's use the charge pump in the intended way. Actually, better yet, let's invert it, because that would be for a negative, right? Capture faster by clicking the arrow start on and off. Oh yeah, no, I know. Like when I did USB, I just turned off all the digitals and all of the unused ones, but I don't really need to sample very quickly right now. So, I mean, this is like, all of this is happening very, very slowly. Actually, maybe it's happening too slowly. It's probably fine. Ah! Did not mean to do that. Oh, that's right. I gotta switcheroo it. Brand new ones have 0 is black and 0 is their ground lead. Yeah, I have one of them where 0 is ground and 0 is black. I wish I could afford one of these, but like if people sold them on eBay used, I would probably buy them, but I have not found any on eBay. Set 13, clear 14. Let's try that. Let's go for 10 seconds. Interesting. So it is a... Wow, this is really awful. Okay, Ben, I'll buy that. I will buy that. This is way too nasty. Wait a minute. No, it's not. That's fine. The noise is in the couple millivolts region. Okay. Anyway. Still only 4.7 volts. And that's with switching it around. Oh, wait, that's wrong. It should be spiking down and back up. So set, both set, clear 13, set 13, set 14. So that's not what I'm seeing. Let's try not printfing anymore. Oh wait, we're not printfing. Are we printfing? Where's the dot coming from? Oh. Make, clean, all, burn, and sear term. I was working in the wrong folder. Oh man, I wish I was following this chat thread. Okay, let's see, what is going on now? Hey, buddy! 9.23 volts. That sounds like it might be enough. Haha! That looks pretty sweet. Except, what's that? That's terrible. Oh, interesting. That looks like the beacons. I wonder why that would make it so bad. Why would there be 9.8, 9.7? That's a huge voltage difference. Maybe I need to monitor the 3.3 volt rail. The wrong pin. Okay, let's see, what does that look like? Oh, you know what? I gotta have to monitor that. Okay, go. Oh yeah, that is what's going on. That's interesting that a drop in the VCC yields a slight raise in the charge pump. Okay, charge pump long term not going to work. For right now, let's just see what happens. So with that, now that we know the charge pump works, yeah, there's no more printf. It's gone. Printf is disappeared. Actually, you know what? I'm curious. What happens if I go even faster? Oh, hey. Sweet, check that out. It's slowly raising. 10.38. Nice solid 10.38. That's golden. Look at that. Yeah! Haha! It's a little bit crazy. Just increasing the charge pump frequency cleans up the rail that much. So right now it's still at less than a kilohertz. Maybe that's the problem. Maybe I just need my charge pump frequency higher. 8. Okay, let's see, what does that look like? So when it first starts, it is very angry when it first starts. Oh my gosh, that ESP is probably like wanting to claw its face off. Oh boy. Once it gets moving though, takes, ooh, that's a long time, 0.4 seconds. Then it gets up to 10.38, but this is really not, Also, that's very odd that I thought I sped it up by a factor of much more than that. Something else must be going on that's causing this not to execute as fast as I would like. That's right. That has to be one. For the other speed thing. Ben, I could totally believe that. If I were to stick like a little LDO a little bit downstream, drop off another volt, that would probably clean this up a lot. But for right now, I done did something dumb. What did I do dumb? Set that at 50 for right now. This doesn't look right at all. Oh. Derp. Gorgeous. Simply gorgeous. Nice solid 10.38 volts. Okay. Let's see what voltages. This is totally open right now. What voltages are coming out? It's 3.6 because that has a limiter on it. You know what I didn't check? I should have made sure that the photodiodes I intend to use don't have a maximum voltage rating. "32 volts. Yeah, I'm not going to go over 32 volts. Okay, I think we're fine. Oh, next step now, let's solder up. A photodiode. Also going to turn off the these guys. Lighthouses, that's what they're called. And gonna wake up. Yep. Let's see, is this gonna turn on? Do you want any of this, I don't even know what you call it. No, it's okay. Yay! The lighthouse is on. IAR is terrible. Man, Ben, you and I really share some opinions here. I will admit IAR has done some things in assembly that I have never, I just kick my butt, but at the same time, everything else surrounding it has turned me off from it. And Kyle, yeah, I don't know. Ben, I'm really curious, what do you think about straight up GCC? Because GCC is my go-to even on commercial systems now. For a long time I was kind of stuck in the world of proprietary compilers, but eventually I just gave up and switched back. Actually, does anyone else here have an optimized ARM library? Yeah, does anybody else here actually really prefer any of the other environments, like more than GCC. I'm just really curious because I've met people who used to feel that way, and now Clang. I have never used Clang. I've done lots with AVR GCC, but I've had trouble with it recently because it really needs the -F LTO flag to do anything useful, and I don't know. Recent builds I've had a hard time with -F LTO. I say to do anything useful. It just when you use -F LTO, it uses up much less much less space, code space. I always end up going for GCC in the end. Yeah, that's totally the feeling. I'll start off with something else and it just ends up at GCC. I'm really curious though. Hey Ben, so when you say Clang, what embedded systems does Clang run on? Because I have heard nothing but good things about Clang, though I have heard limited things about Clang.
I like that name.
And Adam likes the name Clang. Oh, come off. So now that I've debugged all of the charge pump circuitry, I'm going to disconnect the logic probes from it. I think the TLDR from that is, yes, you can use charge pumps on the ESP8266. Yes, they work. No, they're not clean or reliable. So your mileage may vary. Okay, so I'm going to go probe this input pin. I'm going to probe input minus. I'm going to probe input minus as it goes into the chip. I'm going to probe the output. And I'm going to, uh-oh, that's not going to come off. I'm also going to probe the pin that goes into the ESP itself. Uh-oh. Pins are falling off, man. Let's add some solder. Clang is just a C++ front end for LLVM. LLVM supports everything. Does LLVM actually support AVRs? And actually, second question, does LLVM support Tenselica? Because if it does, I will be really tempted to go port, what's his name, Fabrice Bellard's AVR, or sorry, his JS Linux towards the ESP8266, so I would be able to have a browser that could recompile the code to, like, you could take C code and compile it in the browser for the processor. I think that would be really cool. Okay. So I want to reverse bias this. Plug the minus side into the plus, and the plus side into the minus, and hope it doesn't blow up. Okay. So right now I'm going to hold it straight on. Oops. Wait, that's confusing. Man, when the Wi-Fi circuitry on the ESP8266 goes, it just takes it out. Ugh. So 6 and 4 and 5. So 5 is the power. Oh. Hi, Jess. Power, so 4 is this here. Oh my gosh. Yeah, okay, fine. A charge pump is not going to work. Look at that thing. It's just a complete mess. Okay. I'm thinking this is a no-go. We're going to have to be a little bit smarter about how we sure that that's actually the pulses. That should be there to there is. How do I want to view. How do I view that? How do I view the show it to me in hertz. Whatever, that's 120 hertz, I already know. So that's that, and then there's that thing in between, and there is this absolute terrifying charge pump. Okay, fine. Let's up the frequency. Oh, that's not even hooked up. Okay. So pins 2 and 3. Let's look at 2. Yeah, 2 and 3. 2 is sig minus. 3 is sig plus. Yeah, that's not gonna work. Okay, the topology of this is not going to work. I'm definitely going to need a different topology. The reason not to use the 3.3 volt op amp. I was just concerned about maybe it not having a high enough frequency response. That is honestly it. And so I just assumed that that would be a bad thing, so I didn't even go for it. Though I'm really curious why this is not... I'm really confused why channel 6 is not... Okay, maybe I will just back out and we'll just use the dual op amp. Let me just dink with this a little bit more, but I have a feeling that we will be switching out to this guy right here, the TS462. I'm gonna give that a shot. Man, why does it have to be so expensive? 60 cents a piece. Ugh. Oh, it's just the perfect part other than that. Let's see, what is the frequency response like? Oh, it doesn't even have a frequency response graph. Okay, that's why I didn't want to use it. There's no graphs. I have no idea what this part actually does. Although 8.5 megahertz... Yeah, okay. Well, Man, that is a quiet signal. Wait a minute. Did I put this in backwards? Oh my gosh, the AVR or the ESP is also cooking itself. Okay, this charge pump thing was just dumb. Alan did tweet a sensor schematic, but Alan's sensor schematic is for if you want to have the enveloping, which I do not want. No, that was definitely right before. Oh, that's a good point, Ben. If I used a schematic, I would still be able to use the op amp in the front end from it and just have to chop off the back end. You make entirely too much sense. So let's take a look at this. What am I actually looking at? I don't know which op amp he used. Does one of you guys mind looking up which op amp it was? That's Slack. Yeah, if somebody can look that up. Right now I'm using a Sele. Can somebody look up the schematic that Yates did up? Man, what was I thinking with this? There's no way this is gonna work. This is so janky. So sig minus. That really is gonna have to get some sort of pull up. Sig plus. Oh, if I use... I'm thinking it is best to abandon this now, because I'm not really sure how I would change the architecture. Only a single op amp phase? I mean, I guess that's actually enough. I never thought to look at that. But now that I see that it's... I mean, this is not from across the room, but... I mean, that's pretty clear. It's... 2.9 to 2.7. Maybe it is enough. Let's take a look. What is this? Oh, well, the TC whatever needs needs a higher voltage. Does this not include a... Oh, it's just a comparator. What speed? That's interesting. I've never seen something with a propagation delay that long, but that short of a response. No, I got it. I just, up here when I looked at it, I saw something. Anyway. Oh, I was looking at the absolute maximum ratings. Okay. Anyway. What does the actual response time look like? So that's that. Is that fast enough? 500 nanoseconds? Ugh. I wonder if there's a phase delay, or if it just can't respond that fast, or if this can actually respond at the 1.8 megahertz that the lights operate at. Yeah, this doesn't... I don't know how this would operate that fast. I mean, that's a long time. Oh, it's the envelope comparator. Okay, that makes more sense. Yeah, so if anybody gets me what the op amp I should be using in the front end is, that would be super cool. For right now, though, I will admit I don't think there is any way. There is no way this is going to get cleaned up good enough to use. This is the signal, and that is the noise, and this is the signal like a foot away. So actually, I wonder how the size of this compares to the size on these guys. Be right back. Currently, I was just going to decouple it and put it into a cap to the other end just to take a peek at it. So let's see here. We need oh, buddy. Huh. I'm going to need a different photodiode, too. This is downright embarrassing. Why can't I take a picture? Dearest camera? It was wrong. Can't take a picture or a video. Okay. The heck, camera? This camera doesn't want to take any more pictures. What did you want to zoom out for? Or what did you want me to zoom out of? Yeah, the die on that guy looks way bigger than the die on mine. But that's still, I mean, okay, I'm going to need a bunch of different stuff. By the way, the bump in the signal is definitely from the lighthouse, because you can see the bump here, and then a little bit later is the bump from the sweep. And this lighthouse is currently in A mode, so... And you can see this one a little bit further and this one a little bit further, or back. So it's definitely from the lighthouse. The bumps themselves, I believe, should be spaced at 8.8 milliseconds, or 16.6 between this pair, and it's 16.6 between the pair. So yeah, I'm definitely seeing the bumps, but it is getting lost in the noise of the charge pump. So that's unfortunate. Actually, now that I think about it, maybe I would be able to coax this into just a few extra components. So that's there. It's going to that. So you really should be close. I'm guessing they're outside of common mode. So if I put a resistor between here and 12 volts, that should bring it back into common mode. Maybe. About a 10K. Okay, I'll go do that. I'll throw that in. Let's go slap this resistor in here. Zoom out of this. Why such a specific frequency? That's not even the NTSC frequency, is it? No, it's not even NTSC. I don't really need this signal anymore. Oops, I just made a eutectic. Every now and then when you use business solder paste, you get something at the junction that you don't want. It's very rare, but it is hilarious. go aim this back at the lighthouse. So there's the classic notch and thing, but I still don't see any response. So let's see. Sig minus. Why is sig minus so low? That doesn't make any sense. Oh. Well, that's embarrassing. Why is my voltage so low? My charge pump voltage is now at 2.9 volts. And oh, Mark, one of the Selays. Huh. Yeah, I just noticed the voltage drop there. Yeah, the charge pump is not able to keep up. I'm curious if I drop the charge pump frequency if that improves it, but I'm guessing probably not. So 7.7 microseconds, and now it's... Wait, what? It should be slower than that. I've got to be doing something stupid. Oh. What? Why is it 7 volts now? Yeah, 7.7 volts. Here's the lighthouse stuff. It's definitely above and below, but I don't see any output. Also, that's really rough on the ESP. That means that 6 volts is going into one of the GPIO pins. I don't... Okay. I got a 9-volt battery, but I don't think it's going to get any better. I'm pretty sure this is just a dumb topology, and I should probably give up on this topology. But, sure, whatever. I'll just turn off the charge pump. Maybe another day. Maybe another day. No, I have a resistor between the output and the GPIO pin. It will, yeah. So the ESP actually has a funky bit of protection circuitry on the inputs. It's so that you can drive the ESP's inputs with 5 volts or even higher, and it won't hurt it. But I don't know if they've ever actually come out and said what the maximum voltage you can put on the pins is. But no, I do have the resistor there. I have a resistor right here that goes into the I2SI thing, and it's a 10K resistor. But there's almost no power being dropped on it because the inputs on the ESP are just funky like that. At any rate, let me go measure this voltage here. Yeah, it's almost 0. Time to hook up a 9-volt battery. I don't know where any 9-volt battery connectors are. I'll just have to solder right onto it. Don't try this at home, kids. Let's see, what does this thing say now? Why not recompile? Where is this mess coming from? What? What? What's going on? Where is the noise coming from? Oh. Wait. Channel 0 and 1 aren't even connected. But they're seeing the same noise that everything else is seeing. This is getting weird. Is there EMF somewhere? Oh, maybe the ESP is causing the EMF. Uh-oh. Let's see, what does that look like? Blast the snot out of this thing. Well, apparently if you get loud enough, you can see the output. Look at that, so nice and clear, 6 volts to 0 volts. Yeah, that's excessive. There's still that mess, though. I don't know where it's coming from. Ah. Hee hee! Well, at least that's cute. Sweet, that's the 1.8 megahertz carrier. Yeah, I stopped driving the charge pump. How about this? I'll solder on a wire and make sure I stop driving it. I'm getting really confused. So pin 1 is now tied to the pin that the charge pump was on. So there's absolutely nothing there. It is absolute, I mean not pristine, but it's pretty clean. So that means my noise is coming from somewhere else. Not sure where. I guess I could disable the Wi-Fi in the ESP. Mode. Oops, didn't mean to click that. If it's the Wi-Fi engine in the ESP, this could put the nail in the coffin in this a lot earlier than I was hoping. Uh-oh. Oh, man. Why is the Wi-Fi engine in the ESP so noisy? No, it's still happening. Oh, it's just this is closer now, so you don't notice it. Okay, never mind. I'm going to ditch this photodiode. This definitely did not go the way I was planning. Not that, I had a plan, but... I expected more than just, oh, the charge pump works perfectly and nothing else works. I guess the charge pump is about the simplest part, though. Curious what this guy it looks like. Huh. Wow. It's a pretty big difference. Yeah, you can totally see the 1.8 megahertz signal with this, but I still see it. What in the world is that? I wish I knew what that was. Oh, yeah. No. So there's definitely EMF somewhere else. Right now the ESPD266 is off. What in the world is going on at my house that's causing this? I don't know. Maybe. Actually, you know what? We can find out what's causing this. GPIO 0 is now disconnected. Look at that glorious noise. And it is exactly the frequency of the terribleness. Okay. Where in the world is that coming from? Let's go near the laptop. Okay, let's see, did that change much? You know, we should probably slow this down some. Okay. I'm going to disconnect everything else now, because if at least we can figure out where this noise is coming from, that'll help me tomorrow. So with everything unplugged, great, the noise goes away. Just like that. Okay, how am I supposed to debug this? Seriously. Let's hook the ground back up. Okay. So I'm going to go take this and this, standing here, and standing here. I'm an idiot. This is a huge ground loop. There's no way this would work. What? Oh, it's so stupid. Oh. No, the problem is that the Sele is grounded to my desktop, as is the power for this thing. And that's... Now if I unplug that, let's see if that... No. Something else is still going on here. There's still the same stupid... What is the period on this? 9.6 microseconds. What in the world happens at 9.6 microseconds? Okay, what? I get the offsets, but the amplitude is still the same. I know. I think the amplitude got bigger. No way. I'm jumping to conclusions here, but I'm thinking I spent a little bit too little money on the power supply in my computer, because this little blip here is when I touched the shell of the power supply with my finger, and this little blip here is filled with that same period of awful noise. No, it's not. Okay, so never mind. I jumped to conclusions. I don't even know what that is. Oh yeah, no, it's 9 point whatever microseconds it is. I'll unplug everything. Let's unplug this. Actually, I can test my theory really fast. What I can do is I can switch over here to my laptop. Add XSHM. Hi. Okay, and you guys still get text. I'm going to unplug the Sele. Unplug the Sele in here. Do I not? I do have USB 3.0. I got bad news, guys. I don't think it's the laptop. Because that's when I touched the computer. Okay. Next step is we turn off the desktop. Oh wait, I said reboot. I meant shutdown. If it does anything. Dearest computer, please, do the thing. Or don't. Okay, let's try this again. My desktop is now off. It's just the normal 60 hertz for my house now. Okay, I bought a Chinese power supply that was too cheap, and it is messing everything off. I have half a mind of just hooking my desktop up to jumpers to my truck right now. Sounds like the right answer though is to, we've gone down this path a little bit. A charge pump is possible. I don't think it would add that much noise. Actually, we can find out. Since we now know that we have to do everything with my laptop here. Git pull. I've forgotten the repo name. My PSU is a funky Chinese 12 volt LED power supply strip thing, which was not intended for use in a computer. But it works really well on the computer, it just doesn't work really well for everybody else around me, I'm guessing. Unplug the ace. Okay, let's plug everything else back in. I use a Pico PSU for all the non-12 volt rails. I'm sure that thing's crystal clear. I didn't really stop to think about how nasty the other supply would be. Okay. Oops, that got undone. So I'm going to probe D plus, which is this one, D minus, which is this one. I want to probe the op amp's output, which is this one, and I want to probe what's going into the ESP, which is this one. Okay. Oh my gosh, it's so much cleaner. It's also way too loud, but oh my gosh, it's so crystal clear. I'm thinking maybe a charge pump is a reasonable thing to do if we have to use this. Look at how clear that is. Oh wow. Oh, that is interesting that, huh. It's like the LED's response time isn't actually as good as I thought it was. It was reasonable. I guess I'd have to increase the resistance of the pull-up. Why would I want a scope? I have this thing. Yeah, I really should have a ground loop isolator for it. I didn't know that they make cheap ones that are USB 3.0. Man, though. Okay, so the answer is there's really no problem with the charge pump system. Because that's what 3 here is. And I mean, it is just rock solid. Wow, that's clean. Something else is going on here with, this is D plus, so -3 plus that. This is always dawdling around 0.1. I'm not really sure what's going on there. The output is always 6 volts, which is fine. I could monitor that. It's actually going into the ESP. Oh, so clear. Something's just hosed going into the ESP. Oh, nope, I plugged it into the wrong pin. That's the charge pump pin. Somehow I don't really understand how the charge pump can be that crystal clear. That's just so clean. You just don't see it. This is what's going into the ESP, 6.2 volts. Yeah, that's a little weird. 0.1 for 1. That means that the too high of a voltage there. Not sure why the op amp isn't going low. I don't really care at this point. I'm thinking this is just the wrong op amp and the wrong solution. Okay, well, thank you everybody for sticking around. Yeah, this is just I'll scope it out. Okay, sure. Let's crank it. Actually, I guess the ones I really care about are pin 3. Because that has the power coming out of the charge pump. And pin 0. Because that's the one that's coming off the main system. And I can do that at 50, so. Let's do that again. Ah! Oh well. Charles's mess of wires is just about done for tonight. Yeah, I'm looking here and I don't see anything, any sign of that charge pump being sad. And it just looks golden. All of this just looks golden. Well, that was fun. Definitely gonna have to play with this some more though. Thanks for tuning in, everyone. This was fun. Yeah. So, I don't know if it's going to be Hackaday worthy, but it definitely looks like you can definitely get a charge pump running on an ESP. And the ESP doesn't seem to care if you shove 6 volts in its inputs, so that's kind of neat too. Thank you everyone for coming out. It was a lot of fun.